February, March 2023, paper 6, variant 2. Yeah. Question 1. Soon determines the diameter of a marble by two methods. He calculates the density for the material, okay, of the material from which the marble is made. Okay, measure the length D using the ruler, and then using your value of D, calculate the average diameter D1 of the marble. When you measure the diameter using your ruler, probably it would be slightly less than the answer in the marking scheme. The marking scheme had an answer of 7.8 centimeters. If you measured, okay, if you measured the diameter using a ruler, it could be 7.6, 7.7 centimeters, which is not wrong. Again, this has to do with the printing of your papers or of your book. How can I find the diameter of one marble? How can I
نعمل
find
7.8 divide 5
divided by 5? Because we have 5 marbles, so 7.8 divided by 5 would be
1.56.
1.56, or we can just write down 1.6 centimeters. Suggest why is it more accurate when using a ruler to measure the distance D for 5 marbles rather than diameter of only one marble? Why would it be more accurate to measure diameter of 5 marbles?
The percentage of error will be less.
Yes, definitely. The percentage of error would decrease. Percentage of error would decrease. Okay, we have another method. Two wooden blocks. Describe how the student uses the two wooden blocks and the marble to determine a new value for the diameter of a marble. It's quite easy. Quite easy. Yeah. What will he do? Very simply. Hmm.
Put the marble between the wooden blocks
Okay.
and measure the distance.
Okay. He places the marble between the two wooden blocks and measures the distance between them. Using the ruler, definitely. Okay. Um, you can repeat and take average then. Repeat and take average. Student uses draw a diagram. We did not draw a diagram. Draw a diagram. I have the wooden block, and then I have the marble between the wooden blocks, and then I have yeah. The student uses the top pan balance. Yeah, he uses the top pan balance as shown to measure the mass of the 5 marbles. He measures the mass M0 of a beaker, and then the mass of the 5 marbles. Record the readings. Okay, this is quite easy. 30.8 and 64.3. Definitely, I will need to find the average mass of one marble. Huh, what's II? When I just solved II. What? لا لا no. Okay, use the values to calculate the average mass of one marble. How can I find the average mass of one marble?
هنعمل 64.3 minus 30.8 وبعدها تطلع 33.5 divide
Okay, 64.3 حلو minus 30.8, and then you will divide the answer by 5, which is correct. You have to first of all find the mass of the marbles alone, and then you will divide by 5. You have to divide by 5 because you have 5 marbles, correct? The final answer would be
6.7.
6.7. Okay. Yeah. Any problems with this question? The student pours water into a measuring cylinder. He records the reading V1 of the water. Okay. V1 is 26 centimeters cubed. Record the new V2. What's V2? What is V2?
30.
Mhm. It is 38. Why? Because we take the reading from the bottom of the meniscus. 38 from the bottom of the meniscus. V2 minus V1 over 5. 38 minus 26 over 5, 2.4. Okay, yes, correct. 38 minus 26 over 5, 2.4. حلو. Can I find the density? Yes, mass over volume. I have the mass, which was 6.7 over the volume, 2.4. 6.7 over 2.4. Yeah, 2.8
8.
grams. Correct. Describe one possible source of inaccuracy in this method and suggest an improvement to reduce its effect. One possible source of inaccuracy in this experiment. What did we do? We placed the marbles in some water and then we placed the What could be one possible source of inaccuracy?
If the marbles will absorb the water.
The marbles would absorb the water. Um, hmm. This answer is applicable if the marbles were made out of wood. Okay. If the marbles were made out of wood, marbles usually do not absorb water. Okay. They usually do not absorb water. Okay. Hmm. Yeah. What's your answer?
مستر لو نطلع بس هو مش ممكن احنا بنطلع الماربل اللي يكون فيها زي drops of water.
We're removing the marble. It could have some drops of water. Um,
that will affect the volume of water left.
will affect the volume of water left. طيب, do you really care about the volume of the water left? And in this question, do you really care about the volume of the water left? Okay. One of the previous questions was when we put the cork, I guess, in the water, and then we removed the cork, and then we added a measuring modeling clay. The problem is that in this instance, when you removed the cork and then you added the modeling clay, the cork, while being removed, it could have removed some water with it. Okay, while removing the modeling clay and then inserting the cork again, for example, okay, in this process, it could have removed some of the water with it. In this case, in this question, okay, you're not removing anything, you're just adding the marbles. Okay, you're simply adding the marbles. Actually, I'm really loving your answers. I'm really loving your answers, but we need to think about it, okay, realistically. In this question, do I really care about the volume of the water? No. I don't care if I remove all of the water, it wouldn't really matter with me. It doesn't really matter. So in this question, what could I simply say? For example, okay, one possible source of inaccuracy. One possible source of inaccuracy is what? Let me check. For example, um, maybe he did not take the reading uh perpendicularly in the measuring center. Maybe. Okay, he did not take the reading perpendicularly. For example, he might have not taken the reading from the bottom of the cylinder. Maybe. Okay, that's one possible source of inaccuracy. Another possible source would be the measuring cylinder is too large, or is too small, or the measuring. Yeah. Okay, you have many sources of inaccuracy, but again, you just need to think of a logical one that could be suitable for the question. Okay. One possible source of inaccuracy in the method and suggest one improvement to reduce this effect. For example, I could say a source of inaccuracy, he did not take the reading. Huh? he didn't take the reading perpendicularly. Okay, improvement, take the reading perpendicularly to avoid the parallax error. Yeah, parallax error. Okay. Again, I need to measure the room temperature. What's the room temperature in this question?
21.
21 degrees Celsius again. Describe one precaution that he would take. Yeah, what is one precaution? One very simple precaution.
ياخد الريدنج بديفرنت thermometers
Take the reading ايه؟
with يعني كذا thermometer
Different thermometers? لا لا
عشان لو واحدة مش شغالة.
لا لا don't لا لا that's not one of the precautions we're used to in taking the readings. Usually شباب, one of the most famous someone said stir the water. طب in this case in part A is there any water? Am I taking the reading of the water in this case? No, I'm not yet taking the reading of the water. Question A, I'm just taking the reading of the room temperature. So while taking the reading of the thermometer, make sure that you're taking the reading perpendicularly. That's it. Now, take the reading perpendicularly. Okay? حلو. Soon pours the volume of 100 centimeters cubed of water. Okay, and records the temperature at time 0. She records the temperature every 30 seconds. Okay, this is experiment A. And then experiment B, she repeats the process. She waits until the initial temperature theta B of the water is the same value of the temperature of theta A. Okay, is the same again. So she waits until the initial temperature of theta B, the initial temperature of theta B is the same value of the temperature theta A at 90 seconds in experiment A. Can I write down the initial temperature of theta B? What would it be? What would the initial temperature of theta B be in this question? 85. Yes, that is correct. Why is it 85? The initial temperature of theta B is the same value as the temperature theta A at what? At 90 seconds. At 90 seconds, the value of theta A of temperature it was 85. So this should be the same temperature of the initial temperature. Okay, it should be the same initial temperature of theta B. That's it. Okay, write the conclusion stating how the temperature at T0 affects the rate of cooling of the water. Can I find the rate of cooling? Yes, I can find it. How does the initial temperature affect the rate of cooling? We already know the answer to this question. How does the initial temperature affect the rate of cooling? Any ideas? يلا, any ideas? Okay. Yes. Justify your answer. Yeah. As the initial temperature decreases, the rate of cooling also decreases. ازاي? As the initial temperature decreases, the rate of cooling decreases. Again, we must justify using numbers from the table. Decreases. Okay. How can I use numbers from the table? For example, theta A, okay, experiment A had a temperature loss, okay? Temperature loss of 92 minus 80, which was 12 degrees Celsius. But experiment B has a temperature loss of 85 minus 75, which is only 10 degrees Celsius, which is a difference, quite a significant difference. Calculate the average cooling rate during the second half of experiment A. Again, during the second half of experiment A, theta A 90 minus theta A 180 over T, in which T is 90 seconds. Theta A 90, 85. Theta A 180, 80. Oh, it's quite easy. 85 minus 80 over 90. This would be 0. What?
0.1.
Okay. 0.1. لا ازاي 0.1 0.0555 I guess.
اه
Okay. So 0.0555 it could be written down as 0.056. Again, the unit of the rate of cooling would be the unit of the rate of cooling would be degrees Celsius per second. يلا. Calculate the average rate of cooling during the first half of experiment B. The first half of experiment B اللي هو starting off from 85 all the way to 79.5. 85 to 79.5. Yeah. 85 minus 79.5 divided by T, which is 90. This would be, what's the final answer?
0.06.
0.06. Okay, can you give me two significant figures? 0.0 what?
0.061.
0.61 degrees Celsius per second. Again, the student suggests that x1 and x2 should be the same state whether your results support this suggestion or not. Are they the same value? 0.6, 0.061 and 0.056. Are they the same value?
No.
No. Okay. 0.061 divided by 0.056. What's the answer to this? 0.0.
1.089.
1.089. 1.089, which is 1.09. 1.09 is only a 9% error. This is only a 9% error. 9% error means that it is acceptable, that they are the same value. Okay. Statement, are they the same value? Yes, they are the same. Okay. Yes, the same value. The same value. Why? Again, justification. Okay. Justification 0.056 and 0.061 are very close together. Okay. And we can say that they are within the limits of experimental accuracy. You have to measure the percentage error. You have to measure the percentage error. State two variables which must be controlled so that the comparison x1, x2 is valid. What are two variables that must be controlled? Yeah, quite easy. Anything. Any ideas?
ممكن نقول the temperature.
The room temperature, yes. Volume of the water, yes. Okay. volume of the water, time taken ماشي okay would be wrong okay يلا volume of the water room temperature percentage 15%. Yeah, 15% is the maximum percentage which could be acceptable. Question 3. Again, we have circuit. Okay, we have a circuit with length. On figure 3.1, draw a voltmeter connected to measure the potential difference across the length L of the resistance wire. How can I find the, how can I draw the voltmeter? Again, it has to be in parallel. Has to be in parallel. V between the two ends of the crocodile or whatever. What's the measure of the voltage and the measure of the current? And we need to record them in the table and then measure the resistance. Yeah. Voltage is, what's the voltage and what's the current?
1.3.
1.3. Okay. And the current is
0.83.
83. طيب is it 83 or 86?
لا 86.
86, thank you. Okay, it has to be 86. 1.3 and 0.86. Can I find the resistance? Yes, I can calculate the resistance. R equals V over I, 1.3 over 0.86, 1.5 ohms, yes. Plot a graph R on the y-axis, R slash ohms on the y-axis, L slash centimeters on the x-axis, L slash centimeters on the x-axis. Draw the straight line of best fit. Okay. R and L. He did not state that I have to start from the origin, so probably I will not start from the origin. R starts 1.5 up to 8.3. How should I scale the graph on the y-axis? How should you scale the graph on the y-axis? يلا. Any ideas? طيب, what if I start with 1 and then 3, 0, 2, 4, 6, 8, 10? Okay. If I start off with 1, 3, 5, 7, 9. Okay. I guess this would be okay. Okay. 0, 2, 4, 6, 8, 10. 0, 2, 4, 6, 8, 10. Okay. It would work also. Yeah. The length 20, 40, 60, 80, 100. This is easy. Okay. 20, 40, 60, 80, 100. Again, you could start off with 0. It's not wrong. For this question, you could start off with 0. It wouldn't be wrong at all. Yeah. Yeah, let's plot the points, 20 and 1.5. Let me zoom in. 20 and 1.5. 1.5 would be, you know, 2.5 squares above 1. 40, 3.6. Okay, 40 and 3.6. 3 squares above 3. 60 and 4.2. Okay, 1 square above 4. This is 4, 4.2. 2.3 and 6.6. 2.3 and I'm sorry, 80 and 6.6. 6.6. 3 squares above 6. 108.3. ماشي. 108.3. 8.3 would be هنا. Okay. Quite easy. Straight line. Definitely we have an anomalous result. It's quite obvious that the 60 is an anomalous result. So we'll draw the line and we will ignore the 60. Okay. We will draw the straight line. Okay. Straight line. Okay. Now we can say we have two anomalous. Well, not really anomalous, but they're a bit far away from the line. Okay, one value is above the line, the other value is below the line. Okay, it's not completely wrong. This is a really nice graph. If you draw the line this way, it would be correct. And then to find the gradient, what do I do? How can I find the gradient? Again, I have to use the triangle method. Yeah, triangle method. I'll take 2 points which are quite far away and draw a triangle. I'll complete the triangle, a vertical line and horizontal line. And then I will calculate y2 minus y1 over x2 minus x1. 8.3 minus 1.5. Yeah, 8.3 minus 1.5 over 100 minus 20. Okay. Yeah, calculate the answer, please.
0.085.
0.085. Yeah. The gradient is numerically equal to the resistance. Write down the value of the resistance. All you'll do is write the same value of G. Okay, you'll have to write down the same value of G, and he has included in. That's it. 0.085. Okay. Suggest one practical reason why the student carrying out the experiment may not obtain the same readings. Okay. Why may they not obtain the same readings? Yeah. Any practical reason? Any practical reason? Why might they not obtain these same readings? Hmm. Any ideas?
Mr. maybe different room temperature.
Different room temperature. Um, this is not
ممكن نقول different length in في
uh,
الواير.
different length of the wire, different diameter of the wire would be okay. So room temperature would be wrong in this question. Why? Because we're not measuring the rate of cooling of water. Okay, you're not measuring the rate of cooling of water. This is a circuit. You're finding the resistance. You're finding the current, the voltage. Okay, the length of the wire. mm, but yeah, it could be okay. But an even better answer would be the diameter of the wire. Because, for example, one student is using a slightly different diameter than the other student. That's why they could have different results. Yes, the thickness of the wire or the diameter of the wires could be different. ماشي. Yeah. Planning an experiment. Student investigates the motion of a ball through air. Plan an experiment which will enable him to investigate how the range, okay, of the ball depends on the angle at which it is launched. We want to measure the range. What's the range? Okay, The range is the horizontal distance that the ball travels after leaving the end of the channel shown in figure 4.1 and before hitting the ground. For example, I have a ball, okay? This ball will travel down the channel and then up there. We want to measure the distance, the horizontal distance, okay? The ball will keep on traveling until it hits the ground. We want to measure the horizontal distance, okay? We need to measure this distance. This is the range. This is the range. The only thing I'll be changing in this question is what? It's the angle, the variable angle. This is the only thing you will be changing, the variable angle. Again, plan an experiment that will enable him to investigate how the range of the ball depends on what? Depends on what? It depends on the angle. So the thing you will be changing, the range of values would be the variable angle. That's it. This is the independent variable. The range of values. What's the thing you will be changing? The independent variable. What is it? It's the variable angle. And then state 5 different values for this angle. 5 degrees, 10 degrees, 15, 20, and 25. You could use other angles, definitely. You could say 10, 20, 30, 40, 50. In this experiment, in your plan, you should list any additional apparatuses, explain, okay, how you will conduct the experiment, state the key variables, draw a table, okay, conclusion. Okay, what are the key variables for this question? What are the key variables for this question? Any ideas? Any distance of what? What's the distance? The range will differ, okay? You cannot say the distance. Distance is a very vague answer, okay? Because the range, in this case, is the distance. We have many variables. We have many constants in this question. For example, you can say the, any ideas? No ideas, خالص go. طيب, controlled variables. Controlled variables. What are they? Temperature? No, we don't have any temperature in this question. Okay, you cannot say temperature for this question. Now you can say the mass of the ball, mass of the ball, the height of, okay, the height of this channel above the floor, the height of the channel above the floor. Okay, above the floor. There's another really important variable you must control for this question. The position at which you place or the position at which you leave the ball. Okay. The position at which the ball is released. The ball is released. Okay. Length of the channel. Okay. ماشي. What are the apparatuses I will need for this question? Apparatuses. What are the apparatuses? What do you think we might need for this question? We need
A protractor ruler.
protractor, ruler. Yes, definitely. Balance for the mass, but definitely we need the protractor. Okay, ruler, balance. Controlled variables, apparatuses. We can write down the method. Okay, it's the method. Yeah, for each angle. Okay, what should I do? Just release the ball from the same position on the channel. Yeah. For each angle release the ball from the same position on the channel. Measure the range the ball travels. The ball travels in the air. The air using the ruler. That's it. And then you have to say repeat for, okay, repeat the process for all the, the other values of the angle. Now, repeat the process for all other values of the angles. That's it. This is the method. Um, I have to draw a table. Okay, I have to draw a table. You can draw the table in this empty space. It would be better if you draw the table in this empty space. What are the columns I should have in this table? What do you think? What are the columns you should have in this table? Hmm. You need at least two columns, definitely. You need at least two columns. What are these columns? Hmm. Any ideas?
العمود
Angle. And the unit of the angle is degree. Hmm. What's the other value? What's the other
mass
column?
of ball.
Mass of the ball. Okay, you can write the mass of the ball. It isn't يعني 100% necessarily to write down the mass of the ball. Okay.
The height of the channel.
Again, it's not 100%. Okay, it's not the main column I need. I need the dependent variable, the thing that will be changing. What's the dependent variable in this question?
The range the ball travels.
The range. Thank you. Okay. The range, and the unit of the range would be in centimeters. If you do write down the height, or if you do write down the mass, it wouldn't be wrong. It would not be wrong, but you must write the angle and the range as well. Okay. So you can write you can have three or four columns, whatever, doesn't matter. But two of these columns have to be angle and range. And you must include the units, angle in degrees and range in centimeters. Okay. ماشي حلو. The conclusion, how can I? Conclusion is very systematic, as we know. Conclusion, it has to be systematic. Again, what do I do in the conclusion? Repeat and take average. Repeat more than once and take average. And then record the readings in the table. And then compare the results. Repeat, yeah, for each value. Repeat and take average. Repeat and take average. Record the readings. Record readings in the table. Compare the results. Okay, you can say, what are the results I am comparing? For example, I will compare the results of the different angles with the different ranges. Okay. Different angles with the different ranges. Yeah, that's it. That's it.